Greetings and welcome. So we have found frequency distributions. We have talked about variability of data. We've talked about measures of central tendency. We have calculated standard deviation. And we're going to combine finding the mean of a set of data as well as the standard deviation of a set of data in order to basically gain more information. We're going to have a visual representation of that. All right. Now it turns out if I was to gather a lot of data, all right, a lot of data, all right, so here's some numbers. So this would be some scale, doesn't matter what, all right. Yeah, you should write this down. It turns out that if I made a frequency polygon of that data and my class size was infinitely small, or the number of classes was infinity, and the class marks, all right, or sorry, the class limits were kind of right side by side one another, there was just infinitely many classes, then my frequency polygon would look like this for a lot of data, not all data, but for a lot. Okay? And this is called the normal curve.
Should we draw that?
Yeah. And the area of this normal curve, the area underneath it, is 1. So it represents 100% of all possibilities. Okay? And you can imagine that this is a smooth curve, so it's not like, so if this was just a frequency polygon, right, and I only had classes of different sizes, it would be, kind of like sharp edges. But I have classes that are so small, right, the range between them is approaching 0, that it ends up being this. All right. So this is asymptotic at both ends, so it approaches 0, but technically never gets there. And the highest point on this normal distribution occurs at x bar.
X bar times 4.
And what is x bar again?
Mean.
The mean, right? So I'm talking the average of my data. And it turns out that if I add a single standard deviation to my data, all right, I would have x bar plus sigma here. And over here would be like x bar minus sigma. That typical data gathering would result in the area between one standard deviation above and one standard deviation below. I would typically have 68.3% of my data.
Dude, it's so weird watching you write on the pad.
That's true. I've gotten used to it, though, writing over time here. All right. So 68.3% of your data is one standard deviation about the mean, right? Above and below. And if I go 2 standard deviations away, so whatever this distance is, this was sigma units, right? So add another sigma, and right here would be x bar plus 2 sigma. And this would be like x bar minus 2 sigma. All right, that between those values, I guess I'll use a different color. Oh, a little lag there. So 2 standard deviations above and below the mean would give me 95.5% of my data. So among, right, circles of people who are familiar with statistics, if I was describing an event that was rare, it wouldn't be uncommon for you to say, well, it was 2 standard deviations above the mean, right, for something that was exceptionally rare, right? Like our baseball team hitting, say, 10 home runs in a row, that would be assumingly a rare event. I don't think we do that all the time, right? Do we? No? Right. So I would say, if that happened, I'd be in the crowd and I'd turn to someone and be like, man, this is so uncommon. This is 2 standard deviations above the mean, right? And then they just be like, yes, maybe they
just
had.
like slowly move away.
And then I'd bat that pipe and monocle off their face and be like, no smoking on school grounds. And I'm sorry about your monocle. That's what I would have said to them. But they would have agreed with me about 2 standard deviations about the mean.
I think we've had 2.
How do you know if like 95.5 works that number?
Because he's a math teacher. He knows. Because he already studied
Well,
it.
yeah, because we'll know these things. And then if I have x bar plus or minus 3 sigma, all right, we're going to end up getting the percent represented there. Where's my 3 sigma? Would be 99.7%. I won't use green there. I guess I'll use purple. So 99.7% of the data is 3 standard deviations above and below the mean. And then I'll even go out to 4 standard deviations. Plus or minus 4 standard deviations. My sigmas are kind of a little ugly, but you guys can deal with them. So 4 standard deviations about the mean will give me 99.994% of the data is within 4 standard deviations of the mean.
99.994% chance.
Okay? So what I want to point out here is that obviously the data being beyond some of these, like this data here, all right, is less and less likely the further out I get, right? It's going to be highly uncommon. So, and this is how we can kind of represent our basic data. This is how standard deviation can really easily represent the variability of our data, right? Small standard deviations mean my data would be really clustered about the mean, right? A large standard deviation would mean my data is really spread out about the mean, okay? And I'm able to use this and basically find all sorts of wonderful things about it. So let's jump into a problem here.
X bar.
So let's say, I don't know, let's say I was talking like class averages. Let's say our class average was 72. So that was my mean or something like that. And let's say the standard deviation was, I don't know, 5 points. Okay, so let's draw a quick little graph.
We're going to have spreadsheets this time.
We might do some work with spreadsheets at some point. Let's see.
Because it's a lot easier.
Although most of this we'll be calculating by ourselves off of tables.
Ugh.
So what is the mean in this case?
The mean.
72. So I'm going to have this start counting at 72. All right,
Well,
what is 1 standard deviation above the mean? 77. And 2 standard deviations? 83, right? And 1 standard deviation below the mean?
Is 70, 68. I lied.
67. And then 2 standard deviations below the mean? 62.
You're
Right.
wrong in 83, right?
Am I wrong in 83? I am wrong in 83. Yeah, that's 82. Blam. Good catch. Actually, scribble.
Or
Right. There we go.
okay, bingo. 2 normal 2s and then a curvy 2.
Good catch. So those of you who are maybe new to my YouTube channel, I don't know if you were aware of this, but if you can find Mr. Waddy 2s that are written 2 different ways, apparently bingo is what's said. I didn't know that part of the rule, but yeah, that's one of the Waldos to be looking for in my YouTube videos. So the first one to comment under my videos that notices the 2 2s and can timestamp it, it should be something. I don't know.
Something,
Maybe they get a shout out. Like in my next video, I'll say their
I'll
username.
thumb up your comment.
Yeah, I'd thumb up it. Yeah. What?
I thought you can't use your
No, YouTube.
Like, yeah, using your YouTube login. I don't know who. So I'm live streaming this right now. There could be some weird random person on the internet watching this.
I hope there is.
Weird.
Being
I
like-
hope he comments.
Or, or maybe they're just the best person in the world watching this right now. Maybe.
Bill Gates.
Wait, so if I went on my computer right now, I could listen to this right now.
Yeah, just like when I was live streaming from home.
I will. I'll go on. I will comment on
So, guys, let's answer some questions. First of all, what percent of students scored between let's say 67 and 77? So, now there's a couple ways we can...
68.3.
68.3. How did you know that?
Because you told us earlier.
Because I told you earlier. Perfect. Right? Because that was one standard deviation below and one standard deviation above. Right? So 68.3% is correct. Now, so I would call this my P, the percent, and I would call my T value. All right, now there's two types of values we're going to be interested in. T values are going to be, maybe I'll describe it right here. So T values are going to represent the number of standard deviations, so number of sigmas above and below the mean. Okay? Z values will be the number of sigmas. Let's see. Actually, wait, let me phrase that differently. It'll be the...
Dinkelberg.
No. Let's see, the number... It's difficult to phrase this one. Number of sigmas.
Sigmas.
That.
What is that negative? There's that Z value.
Yeah.
From the mean below which
From the...
a percent of the data is. It is not above.
Mr. Wani, I just ran out of room.
Sorry, I just did two a little bit. So T values, let me describe both of these situations here.
Data. And
To draw two quick little swoops here. So a T value would be about the mean. And a Z value would be everything below this point. All the way off to negative infinity or whatever. Okay?
Okay.
So this is so this would be x bar plus or minus sigma, where it'd be like some t number of sigmas. All right, and this would be x bar plus some z number of sigmas. So if t is 1, like in this case, all right, then the p-value was that. So it's just kind of a little bit weird to get used to. But t was 1 in this case, all right, because it was one full standard deviation above and below the mean. And on our chart that I just made available to you guys, your book has a little chart as well, by the way.
Made?
I made, that a particular student made copies of, but I created this myself in Excel, thank you. It is found in your text, a portion of it on page 919. However, this chart has way more detail. So it says percentages in a normal distribution. So I had to analyze my problem and realize we were in an about the mean situation, right? Because we were above and below. We were given kind of a range. So I knew that I had to work with t values and not z values, okay? And since my t values, I was one full standard deviation above the mean, I went down to t equals 1, and p is the percent of the data that is one standard deviation above and below the mean. Okay, so then I could look up that value, and there's my 68.3%. I've got way more decimals than the book does. For fun. I don't know.
Funsies.
For funsies, because Excel could do it without much effort. So let's ask this question, and we're almost on lunch break here. So what percent of the students
B. Bottom.
scored less than, there's the L. I was trying to figure out why I said scored. It was because I was combining scored and less. Less than, and let's say less than 82. So 82 is how many standard deviations above the mean? 2 full standard deviations. Okay? And is this a t value or a z value situation? Z, because I'm looking at just the ones less than that. So z is equal to 2 here. And now I'm looking up the percent.
I get it.
So here's my t chart, or sorry, z chart. This is z chart. Z chart. And I get, when z is 2, I get 97.7%
It's not that hard.
of the data is less than 82.
Wow.
Because it was 2, because it was 2 full standard deviations above the mean. Right? So, and we're going to extend this after our break and do a lot more different types of problems, but I'm going to pause right now.